Hi, hello. Myself Naveen Bangera, lecturer in Polymer Technology, Department of Polymer, Karnataka Polytechnic, Mangalore. On behalf of Department of Polytechnic and Technical Education, now I am going to present the following topic. Course is Rubber Processing Technology, 5th semester. Brief introduction to elastomers, Unit 1, Session 4. Course outcome. At the end of the session of Unit 1, the student will be able to understand raw materials used in rubber industries and their applications. Now we go back for recap of previous session 3. We discussed in session 3 about natural rubber, about polyisoprene rubber, about SBR, and about polybutadiene rubber, and multi-choice questions related to the session 3. Now in today's class, we will discuss about butyl rubber, discuss about neoprene rubber, discuss about nitrile rubber, discuss about silicone rubber and EPDM rubber, and MCQs of session 4. So first, butyl rubber. So butyl rubber is a isobutylene isoprene rubber, or IIR. A butyl rubber is a synthetic rubber. It is a copolymer of isobutylene and isoprene. It is also called isobutylene isoprene rubber. It is based homopolymer of isobutylene, that is polyisobutylene C4H8N. Both William Sparks and Robert Thomas defined a convention by copolymerizing isobutylene with a small amount of isoprene. Isoprene provides extra double bond which is required to cross-link. So if isoprene is not there, this is fully saturated rubber. So fully saturated rubber, we cannot vulcanize the rubber. So we need a small amount of isoprene to cross-linking. That is why isoprene provide extra double bond which is required to cross-link. Initially, a butyl rubber was called butyl-butyl. Later on, it was widely accepted for its low permeability to gases and its excellent resistance to oxygen and ozone. So, Q system in butyl rubber. Because of very low level of insaturation in butyl rubber, there are relatively few locations at which cross-linking can be achieved during vulcanization. For this reason, more active accelerator, particularly the thionyl sulfides and dicarbonates, are used along with system to cure butyl rubber. So now, structure of the butyl rubber. See here, isobutylene structure. So total 97% of isobutylene combined with 3% of isoprene. So small proportion of isoprene here adding to this isobutylene. And then we get this structure as butyl rubber. Properties of butyl. Symmetrical structure and regular arrangement. Second point, low resistant applications. Third, low gas and moisture permeability, high resistance to ozone. So, since it has got very low moisture and gas permeability, so it has been used largely in the tire industry as a inner tube, or automotive tubes. High resistance to ozone, weather, abrasion, tear, flexing, heat aging, chemical attack, excellent electrical insulation performance, and high shock absorption. So, fourth point, that's last transition around minus 70-degree temperature. Last transition temperature minus 70 degree. Uses of butyl. One, used for irrigation tubing, that is in agriculture, sheeting, tank linings, roof coverings, cable insulation, gaskets and adhesives. Second, it is mainly used in tire inner tube because of its outstanding resistance to low permeability. Tire curing bladders, sealants, sporting goods, gloves, injection molding compounds, and load bearing pads, inflatable goods, and variety of automotive parts like body and engine mounts, radiator hose, etc. So it is mainly used in tire inner tube. So tire industry, the large quantity of this butyl rubber has been used. So next polymer is the neoprenes. So neoprene, that other name is chloroprene rubber. Introduction. Neoprene is the generic name for polymers of chloroprene, that is 2-chloro-1,3-butadiene. Introduced commercially in 1931 by DuPont, United States. So DuPont offers total 23 types of solid neoprene, and 16 types of neoprene latex. So manufacturing 2-chloro-1,3-butadiene, the monomer from which all neoprenes are made. It is produced by two major processes. One is by acetylene process, second one is by butadiene process. Generally, most chloroprene is produced from butadiene process. The neoprene structure, polychloropropene or neoprene or CR. CR means chloroprene rubber. Properties of chloroprene. Appearance, colorless, it's a colorless liquid. Odor, pungent, ether-like. Density is 0.95 gram per centimeter cube. Melting point 59.4 degrees centigrade. Solubility, soluble in alcohol, diethyl ether, miscible in ether, acetone, benzene. Next, uses of synthetic polychloroprene. So, first one is wire and cable covers and tubes for hose, conveyor belt for industrial or mine services, V-belts, power transmission belts, molded and extruded products. Next, neoprene are used to make adhesives, coated fabrics, soles and heels and roof coatings. Next polymer is nitrile rubber. The copolymers of butadiene and acrylonitrile are known by several generic names: Bunaion, nitrile rubber, and NBR. The most popular is nitrile rubber. NBR is the accepted polymer for oil, solvent, and fuel and grease resistance. Over 300 grades are now commercially available, from which the rubber industry can choose polymers that will satisfy the most of its demands of modern rubber mixing and processing methods. The expertise in compound formulation design built up over the 40 years since NBR was first introduced has also made it possible to improve the final properties of NBR compounds in order to meet new service conditions. Now structure. See, this is the structure of nitrile rubber. Next we will go for nitrile rubber properties. 1. Nitrile compounds have excellent abrasion resistance. Second point, excellent water resistance. Third point is excellent oil and chemical resistance. So, nitrile rubber is very familiar for its outstanding resistance to oil and chemical resistance. That is why, or in all oil, or for example, rubber used in oil field are manufactured by the nitrile rubber. Fourth point, heat resistance. Alternatives of nitrile rubber are generally considered serviceable up to 121 degrees centigrade for continuous use. Fifth one, nitrile polymer have excellent resistance to gas diffusion. Next, uses of nitrile rubber. In automatic transmission seals, fuel lines and hose, beverage dispenser seals, fuel pump diaphragms, printing roller and plate gums, oil resistance clothing and aprons, industrial gloves, hydraulic hose. So next comes silicon rubber. The silicon backbone is composed of silicon to oxygen linkages. So this silicon rubber is an inorganic rubber. So inorganic backbone is composed of carbon to carbon linkages, whereas inorganic rubber, that is silicon backbone, is composed of silicon oxygen linkages. This chemical bond is found in other high temperature materials such as pots, glass and sand. They are called inorganic polymers because main chain does not contain carbon. So curing is done using peroxide. For example, for peroxide, dicumar peroxide, that is DCP, etc. So structure of silicon rubber. This is the structure of silicon rubber. The main backbone, see here, silicon and oxygen linkage, silicon and oxygen linkage, silicon and oxygen linkage, silicon and oxygen linkage. So whereas organic rubber, this linkage becomes carbon to carbon atoms, carbon to carbon, whereas silicon to oxygen linkage. That is the difference between organic and inorganic rubbers. Silicon rubber properties and uses. Properties: high temperature stability. So silicon rubber is very familiar for high temperature stability. So it will withstand up to 350 degree centigrade. So it has excellent resistance to flexing fracture. excellent ozone and corona resistance. Compression set is superior. Oxygen, weather, ozone resistance are excellent. Permeability to gases is excellent. Uses: fire resistance barriers, roof and tank insulations, prosthetics, mold making for bioengineering components, electrical industry, construction, food, medical, metallurgical industry, resistance to biological fluids, so used in medical applications like implants, airport insulations, fuel tank in cars. Next comes EPDM rubber. So EPDM, that is ethylene propylene diene monomer, is a synthetic rubber made up of ethylene, propylene and diene monomers. So ASTM is designated this rubber as M class rubber. Its molecular structure has a single bond chemically saturated backbone, which makes it extremely resistant to outdoor conditions. This is because ozone and ultraviolet rays aren't able to break up its molecular structure in the same way as rubbers with double bonds. Now the EPDM structure. So this ethylene, propylene and a small diene. This structure you see, ethylene and propylene, is EPDM rubber, so without diene, it is a highly saturated rubber. So the small quantity of diene is introduced to this chain to vulcanize this rubber. And EPDM properties of EPDM. EPDM's biggest advantages lie in how weatherproof it is outdoors. It can't resist abrasion, UV rays, ozone, aging and weather, and it's the most waterproof rubber available. EPDM is also steam resistant, functioning in up to 392 degree Fahrenheit, 200 degrees centigrade, without air and chemical resistance, including the polar fluids. With the similar properties of silicon rubber, below 250 degree Fahrenheit, the EPDM is resilient, has low electrical conductivity and adheres easily to metals. It also very flexible with 600% elongation and a tensile range of 500 to 2500 psi, while functioning well in temperatures from minus 50 degrees Fahrenheit, that is minus 45 degrees centigrade, to 350 degrees Fahrenheit, that is 177 degrees centigrade. On top of that, EPDM insulates and reduces noise. Part of the reason it's so commonly used in the automotive industry. So uses of EPDM. In automotive field, this is EPDM's most common application thanks to its flexibility, resiliency and weatherability. It can be found in vehicle weather stripping, seals, sealant, wire and cable and brake systems. It's also blended with other materials to make fender extensions, rub strips and car bumpers. Next comes industrial uses. Industrial applications use EPDM for its electrical insulating and waterproof properties as well as its resilience and flexibility. EPDM can be found in parts such as water system, O-rings, hoses and gaskets, as well as in electrical insulators and connectors for wire and cable. It also takes form of accumulator bladers, diaphragms, grommets and belts. Next, construction line. Thanks to insulating, weatherproof and waterproof capabilities, roofing is a major application for EPD. However, it is also used for sealant, expansion joints, garage door seals, pool and tank liners, and waterproof coating for bitumen roofs. So now we'll go over multi-choice questions. 1. So butyl rubber is familiar for their outstanding resistance to dash. So option is low air permeability, low luxing, low abrasion, and D, low ozone. So which is the answer? So as I told you before, butyl rubber is familiar for their outstanding resistance to low air permeability. Why? Because of this property butyl rubber contains, that is why it has been used in large quantity in tire factories in the production of inner tube or automotive tube because of its low air permeability. Second one is neoprene elastomer introduced in dash. So each year neoprene elastomer is introduced by DuPont. A option 1929, B 1931, C 1935, D 1941. So answer is 1931. So 1931 for DuPont they introduced this neoprene to the field. Third question. DuPont offers dash types of solid neoprene. DuPont offers dash types of solid neoprenes. So DuPont offers dash types of solid neoprene. Option A10, B23, C16, D20. So here the answer is 23. So altogether DuPont offers 23 types of solid neoprene and also it offers 16 types of latex also. Latex neoprene. 23 types of solid neoprene and 16 types of latex neoprene. Here answer is 23. Fourth question. Generally most chloroquine is produced from dash process. Most chloroquine is produced from dash process. Option butadiene process, solution, emulsion, D, none of this. So answer is generally this chloroquine is produced from butadiene process. There are two types of process to produce butadiene, to produce chloroquine, that is acetylene process and butadiene process. So generally most chloroquine is produced from butadiene process. So answer is butadiene process. Fifth one, copolymers of butadiene and acrylonitrile are known as dash. See here, fifth question, copolymers of butadiene and acrylonitrile copolymers of butadiene and acrylonitrile are known as dash. Option A, IIR, B, SBR, C, NBR, D, none of these. So copolymers of butyl and nitrometal. This is here CIAR. This is IIR. This is isobutene rubber. So isobutene rubber means it is a butyl rubber. So it is not correct answer. Then SBR is styrene and butadiene. Styrene and butadiene. This was not correct answer. Then NBR. So it is a copolymer of butadiene and acrylonitrile. So correct answer is NBR. Sixth question. Nitrile rubbers are very familiar for their outstanding resistance to dash. Nitrile rubbers are very familiar for their outstanding resistance to dash. Options are A, oil and chemical, B, heat, C, ozone, D, none of this. Which is the correct answer? So nitrile rubbers are very familiar for their outstanding resistance to oil and chemical. Oil and chemical. So oil and chemical is the right answer. That is A. Next, seventh one. One of the important property of silicon rubber is its option A, low flux resistance, option B, low aroma resistance, option C, high temperature stability, and option D, low ozone resistance. So answer is, silicon rubber is very familiar for its high temperature stability. So it will stand up to 350 degree centigrade. That is why this answer is correct. High temperature stability. Eighth question. Dash elastomer is termed as terpolymers. Dash elastomers is termed as terpolymers. Option A, NBR. Options B, SBR. Option C, PBR. Option D, EPDM. See here, correct answer is EPDM. So EPDM is, see here, why it is terpolymer? Because it has got three polymers. One is ethylene, P is propylene, and this is diene. So three polymers, ethylene, propylene, diene monomers. That is why EPDM elastomer is termed as terpolymer because it contains three polymers, ethylene, propylene, diene. Next, ninth one. EPDM is made up of ethylene, propylene, and dash monomers. EPDM is made up of ethylene, propylene, and dash monomers. So, option A, isoprene, B, neoprene, C, chloroprene, D, diene. So, which answer is correct? That is D answer, diene. So, the terpolymer, that is ethylene, propylene, diene. So, diene is right answer. Next, 10th one. EPDM is familiar for their outstanding resistance to option A, oils, B, hydraulic fluids, C, weathering, D, none of this. So, EPDM is very familiar for their outstanding resistance to weathering. So, it has got very good resistance to weather. That is why it is used in outdoor rubber products. Thank you.